Welcome to another video episode on my Arduino Mega2560, right here, connected to a breadboard with some electronics and a fish technique switch. The purpose of this series of videos is to explore the possibilities with the Octave Arduino package. Octave is a high-level mathematical programming language, scientific language, and with the Arduino package you can perform operations with an Arduino, and currently there are two Arduinos that I have that are supported, which is the Mega2560 and the Uno. So I might add the Uno as well to these experiments. Last time I improved the algorithm quite a bit with respect to the graphs and also to the meaning of stuff, and they didn't quite work out. Everything is controlled by pulse width modulation and read back. So pulse width modulation goes that way, value goes that way, and it's read in analog as well as in digital and by voltage. Voltage is by definition analog, but the Arduino package has read analog and read voltage, and they both read voltage in their own way. So I've been reading through the manual and I think I know my misunderstanding, but I'll have to find out if that is indeed correct. So starting out was in the very beginning of this second series to get something done with this electronic circuit, which is an LR circuit or RL circuit, resistor inductor. In electronics you use the symbol L for inductor. A transistor as well, so it goes first through the transistor and then here, and then with the voltage backlash you get something back, and the idea is to measure that. What do you get back? And here are two LEDs. This one is to indicate the end of a cycle. There are currently 10 cycles programmed, and this one is to measure or to indicate if with the two parts of the cycle both parts are 1 or not. If both parts are 1, then the green LED shows or blinks, and if not, it doesn't. Mostly it doesn't, but we'll see how that ends up this time. With all that said, I have now put probes, and that is not good. This should be right here. So this probe is connected to the input from the circuit. Pulse width modulation. This probe is connected to input as well, but after the switch. Then this probe is measuring the signal in analog value, and this one is measuring the signal in volt. At least that is what I intend to measure. Anyway, let's see whatever happens. So, on with the show, and let's see the software. So, let's go with the first iteration, which is actually 6 iterations, and I have to hold. I have to do two things. First of all, with this algorithm that I wrote in Octave language, press F5 to execute and hold the switch, and then watch the oscilloscope. So things should start by now, and they do. What's up with this? Okay. I have to cancel this because I have to redo the settings of the oscilloscope now. Back to 5 volts. For different experiments I do use different voltage levels, and this one has to be also a different time base, and this is time base of 1 millisecond, which is much better. So let's go again. Go and press. And during the time of overtime, then you will see the results in the graph automatically. And let's now first see the first iteration by means of this LED, which I didn't see, by the way. No, because the wire is out, and that certainly doesn't help. That's not good. Okay, I have to cancel this because it doesn't work like this or this way, and this way things can go not nice. Okay, wire set again, quit, and press the switch, go. There we go once again. Increasing cycle, increasing part, decreasing part, and the decrease is of the upper level. So this one is now decreasing, and that's the part that I'm looking at. And I saw a small flash, so that's one cycle. And now it's decreasing again. Yep, that's another cycle. And so it goes forth. So I'll do the rest off screen and tell you. Alright, so the first run has ended, and this light has never flashed, so that should be visible also in all these values. Forward, 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 forward. See, this is all 1 0. There's never 1 1 under each other, under another. So various values, never one is the same, although never one is not entirely true, because this is 2 times 530 under another. Is there any other thing that is remarkable here? 270 to 90, so that is different. 5 all the time, 5 all the time, 20. Okay, forward again. Yep, one different. Here is here a different value. This is back to 5, and often to 90, with also different values. And there we go with the figures. And that should be logically in this position. This is very different. So if we recall voltage level between 0 and the board voltage, which is nominally 5 volts. Then the voltage varies between 2.6 and 3.6 volts. While the analog value is a value between 0 and 2 to the power something. And if I recall correctly, it is 7 bits. And 2 to the power 10, 2 to the power 10 is 1025. 24. So it is, if it is 7 bits, it would be 512 or something. I should know it by head, by the way. Okay, this is running something, and tab 2 to the power 5, 2, so 7 is 128. Is this 128? Seven bits? No, because I think the max was this 256. But then again, yeah, 2 to the power 10 is then 1025, so 1024. So if you look at this, but why are those values different in time? That doesn't make sense to me. It only goes downwards here, while this goes up and down. And it is one uninterrupted run here, also very strange. Up and down, many peaks. Here are also peaks, but way different. Here A1, there's not even a one single similarity, just like this one. Not a single similarity, which is quite odd. Quite odd. But also I have put the probes different than last time, and now you can see that this one is all high, 5 volts, which is coming from the resistor here, which is now connected again to the 5 volts. But it, when pressed, you can see that the periodicity of the pulse width modulation is visible, but it doesn't come from the circuit. It comes from it doesn't come from the RL circuit. It comes from here. So it has influence, no doubt about that one. Anyway, strange effects. Alright, next point. I did wonder about signals that I got. I added an LED, not really spectacular, just from here to the ground to see what signal is on it. And it burns, not very bright, but it burns. And then while watching this part of the circuit, I noticed one thing. The voltage was always 5 volts. And it was always influenced by pulse width. Then I noticed something else which I didn't like. There's a voltage over the inductor. So why does it show related signals? And then while observing, I noticed it was touching wires. Now it is not. And now the voltage is no longer 5 volts. It is 4 volts, give or take. And when I do this, something happens as well, which is not good. And now you can see that the voltage on the fourth probe, this one, which is getting its voltage back from the system, from the circuit, is no longer influenced by the pulse width modulation. And the resistor right here is limiting the voltage. That's one thing. So it brings it back to 4 volts. And without any signal. So what happens when I now let it go? With that signal, nothing. So I'm going to do another run and see what the effect is in the graphs. I have a little bit my suspicion, but let's see whatever that may bring. So press, and you may notice that this LED here is absolutely doing nothing. I don't know why. Anyway, press. And let's see for one cycle. That was one cycle, so the rest I'll show you afterward. And it says ended again. Long runs, but let's see for the whole thing again. Forward, forward, forward. Okay, this is interesting to see. What does V1 show? No, yeah, oh really, here. 1, 2, 3, 4, yeah. Here, a 1-1 content. So that it, oh, that is strange. 2-1 is set not okay, so why it is one, why is it 1? This is not okay, this is 1, that is strange. Alright, further. Quite similar here. So that will be a straight horizontal line. No double ones again, and here yeah, and here not okay. Well, that is logically, but this one, oh wait, yeah, there were already other ones, so I didn't look early enough for this okay situation. True. And very non-similar digits. Alright, let's take a look at the figures. Okay, this one looks a bit similar. Two high peaks. So yes, I agree with these. This one not so much. No. And this is again unexplainable. Well, one big peak, but what's next I don't know. So this one is alright, the rest big doubts. Not really explainable, and the difference is not visible, or I must or I'm looking it the wrong way, having the wrong thoughts, etc. Possible. Okay, what's next? Yeah, my earlier idea of adding another board, I didn't prepare one, so that I will postpone to another episode. But this conclusion, this is now similar, the rest not at all. I can't explain them. 2 to the power whatever, and that is here. So what to the power 2 is 400. Yeah, alright. Looking at this, 256 would be below. So let me add them again. $512 would be here somewhere. But if I look here, 2.1, 2.2, which should be what? If this is the power, then it should be here somewhere. I have to look more detailed into this, unless one of you has a suggestion. And with these curious results, I say thank you for watching once again. Added this, which gives a not so bright light, so it's not a full voltage. It's not on pulse modulation, because that gives a quite different effect. And the rest with values that I can't explain except for one, but I already said that. Next time I might add the Arduino Uno again, like I did in my previous series of videos. And I might couple it again with SPI or I2C. Anyway, not that far yet. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please support the blog and videos with by doing donation via PayPal or Wired. And you can also become a patron and have your name mentioned on my website, or within videos, depending on the pledge you make. Always on my website. And well, all information is under this video. So URL my website, how to donate, how to become a patron, etc. This is going to be continued. Have a nice day and bye bye.